guys, welcome back. This video contains 28, 29, and 30. So let's do it. Erica has a swimming pool at her house. Once a year, she purchases a 50-pound bucket of chlorine. However, one time she buys a bucket and it's less than 50. She then purchases 4 more buckets, giving her a SRS, or a simple random sample, of 5. The mean weight of those buckets were 48.5. So see how she has some amount of evidence that it's less than 50. But could that have been just by chance? And that's what we do as statisticians, is calculate the likelihood of that chance. Okay, so using this data, she got a p-value. So it is not very likely, but 0.08 is, or 0.0851 is not rare enough. So because of that, you should be remembering the doors in the room. Now, I wouldn't necessarily put this word door 1 and door 2 because that won't mean anything to the grader. But door 1 says we reject the null, and always a possibility is committing a type 1 error. Door number 2 is when we fail to reject the null, and we have a possibility of a type 2 error. So notice that since the p-value is 0.0851, and that number is actually greater than 0.05, we have to fail to reject the null, which means we've narrowed it down to C, D, and E, eliminating A and B. All right. However, we have to prepare not for multiple choice questions, but for writing this out. So anytime we write fail to reject the null and they ask us about an error, if we fail to reject the null, then we could make a type 2 error. Right? And if you're wondering, what is a type 2 error? It means you fail to find convincing evidence when in fact that was true. You really were on the right track. You just didn't have enough evidence, right? In fact, we notice if we set alpha at 0.10, we would have detected it, and we would have been able to walk through door number 1. So that's called a type 2 error. Let's take a look at question 29. Oh boy. Okay. So, a psychology study found men who were distance runners lived on average 5 years longer than those who were not. The study conducted used a random sample of 50 runners and 30 non-runners. Men who were distance runners lived to be 84.2 with a standard deviation of 10 years, and non-distance runners were lower than that, 79.2, and a standard deviation of 6.8. So our question here is, 1, just take all this information out of the problem. And 2, what if this was your question on the test? Free response. So I'm hoping you're thinking, we will perform a 2 sample, because we have 2 sample, t-test for mu1 minus mu2, right? And so we must assume there is no difference between the runner and the non-runner, and that you actually think that the runner is more. And you have some amount of evidence that they do live longer by a handful of years. So if we were asked to state, I stated, I planned, I see an independent random, since you have 2 samples, you're gonna put in that word independent. And I can test the 10%. I gotta do it twice, right? Population of all male runners is greater than 10 times the sample size, 50 times 10. Population of all non-male runners is 30, n times 10. That's reasonable. And notice my sample size based on the central limit theorem, I'm good there. So my conditions have been met. We also think about writing out the parameter because it helps us clarify what it is we're doing. So what we're doing here is we're trying to find mu1 minus mu2, whether or not there is a true difference in lifespan of all male runners versus all non-male runners, and we're using the formula runners minus non-runners. Okay, so how would we calculate this in our calculator? We would go to a 2 sample test and type in this data. Okay, so let's take a look. If I type that data in my calculator, I get these 2 values. All right, so what was happening here? My general formula for T is actually an approximation of Z, which is generically A minus P over S, AP statistics. What is the actual value minus what you'd predict over the standard error of the statistic? So the actual value is just the difference, right? That's what we're calculating. The difference between the two, which was 84.2 minus 79.2. And all of my choices had that. You might be thinking, well, where did the predicted go? Remember, we're predicting there was no difference. So that's why that kind of fell off the problem. And then what's in the bottom? That's the standard error of the statistic. So that would be the standard deviation of the one squared over n plus the standard deviation of the second one squared over n, and take the square root of the whole thing. So that's how we got our answer for C. Oh, okay, so if we finished out with the P value, we would say since 0.005 is less than 0.05, we reject the null hypothesis. We do have sufficient evidence to show that there is a difference in lifespan of male runners versus non-male runners. Okay, last question. Thank goodness. We're given a study and we're trying to find out if exercising after a study, after you're studying for an exam, whether or not that would increase your score later. Now, this is likely not on the test, and that's actually showed on, so you don't have to write anything if you miss this one. It's just some people are interested. So we noticed that it's coming from 3 groups in a randomized experiment. So when we did M&Ms, we noticed there was only one variable. So a chi-squared test for homogeneity is if I take some groups, and here I have 3 groups, right? And I'm only asking one variable. I'm only asking what is your performance on the test later. So that's why it's chi-squared test for homogeneity. Thanks for joining me, guys. Have a good one.